Ask any kid how cotton candy and peas are connected, and you'll probably be met with some blank stares and maybe a few cries of, ew, gross. In the next 10 minutes, we'll show you that the answer to their connection is through an odd intermediary, seaweed. What's more, you yourself can use a seaweed that connects cotton and candy and peas to create. Whoa. We're getting ahead of ourselves. Let's back up for a second. The real hero here is the field of culinary science called molecular gastronomy. Essentially, molecular gastronomy combines physical chemistry and cooking to create new innovative dishes from familiar ingredients. Cotton candy is one of the first popular examples of molecular gastronomy. Anytime you grab one of these flossy pink clouds from a fairground or baseball game, you're about to munch on a simple sugar that has gone through many complex physiochemical processes to become a familiar treat. Now, where do the peas come in? To answer that question, let's meet one of the heroes of the modern molecular gastronomy movement, Ferran Adria. Adria is the famed chef of El Bulli, a restaurant that, until its closing in 2011, was a pioneer in discovering new molecular gastronomy techniques. One of Adria's signature dishes is pea ravioli. That doesn't sound too exciting for someone on the forefront of avant-garde cuisine. Let's look a little closer. This pea ravioli requires no pasta shell. Adria simply drops a blob of pea puree into a special solution, and it pops out a perfectly symmetrical spherical burst of flavor. But how exactly does this work? Let's bring in our old friend, the seaweed. Many seaweeds contain a material called alginate. Alginate is a polymer, basically a long chain of repeating units. Many of the foods you eat every day are composed of polymers, including the starch that you find in bread. Alginate, particularly sodium alginate, behaves in an interesting way when it's combined with calcium. See, when calcium is in its ion form, it has a positive charge. In the sodium alginate molecules, many of the oxygen atoms have a negative charge. Put them together and the attraction is unavoidable. It's so strong, in fact, that the sodium ions attached to the alginate are kicked off the seaweed molecule so that more connections with calcium can be formed. When you combine calcium and sodium alginate on their own, they form just a stable gel. But throw another liquid into the mix and things get interesting. See, Ferran Adria dropping pea puree into a special solution isn't the whole story. He's mixed sodium alginate into the pea puree, which, by the way, is totally safe to eat, and the solution contains calcium ions. He didn't necessarily have to do it in this order. Because of the simple reaction, he could have mixed the calcium ions in with the pea puree and put these little blobs into an alginate bath. When the pea puree enters the solution, the positive and negative attraction between the alginate and the calcium takes place right away, and soon a thin gel forms encapsulating the liquid. This produces something that looks like a mini water balloon with edible skin. These spheres can be eaten alone or incorporated into larger dishes or drinks. They're a fun way to experience a literal burst of flavor. These spheres aren't confined to the high-tech kitchens of famous chefs. You can easily make them in your own kitchen. Because of the skyrocketing popularity of molecular gastronomy, sodium alginate and calcium compounds are readily available. There are tons of calcium compounds that would work just fine chemically, but we're concerned about their taste too. An option like calcium lactate offers an unobtrusive taste and fits the bill for the chemical reaction. Once you have all of the ingredients, making these liquid spheres is as easy as putting a little sodium alginate in your main ingredient, making a calcium solution, and dropping that main ingredient in. To solidify this process, let's put it into action through a recipe that you can try at home. A gin and tonic is a drink whose recipe is as simple as its name. Besides its two obvious ingredients, these cocktails are often garnished with a slice of lime. However, this simple cocktail is about to get a makeover, and here's how. In a mixing bowl, combine 15 grams of gin, 30 grams of tonic, and 5 grams of lime juice. Add 0.15 grams of calcium lactate, then pour the mixture into a spherical mold tray and pop them in the freezer. We didn't need to use this step during the pea puree discussion, but since alcohol has a lower density than water, we want to make sure that the droplets actually submerge in the alginate bath. While the balls are freezing, add 5 grams of sodium alginate to 1 liter of water and stir until all of the alginate is dissolved. Now you're ready to rumble. Carefully drop the G&T spheres one by one into the alginate bath. Let them hang out in the mixture for about 30 seconds, and then carefully remove them with a slotted spoon and rinse with water. While you're enjoying your spherical gin and tonic treat, think about all of the happy little calcium ion and alginate bonds who were formed to create the spherical burst of flavor.